Functions and characteristics of functions. So we have an equation or a function here, and they've asked us to state if it is a function and the domain and range. Now, normally when we're talking about functions, a lot of times they refer to function notation where f at x or something around those variables is equal to something, and that usually stands for y. So in this question, we have the variable y. We want to isolate it and get y all by itself. In order to tell what to move and what not to move, if there's an addition or subtraction sign behind things, or sorry, between things, that makes them separate terms. So this is a term, this is a term, and this is a term. So essentially we have three terms right now. Because we want y by itself, we want to move this term to the other side of the equation to start. So we're going to take this term, 3x squared, move it over. So then we're left with 2y is equal to 6 minus 3x squared. We're still looking at getting y all by itself, so in order to do that, we need to divide every term by 2. So the way you wrote it was kind of like this. We divided both sides by 2. Nothing wrong with that. But what I do want you to recognize is this now becomes y equals 6 minus 3x squared divided by 2. Okay. When looking at a function, they usually write it, like this might look odd to us. I'm not quite sure what it's supposed to create. That's because the way they usually write a function in textbook that's clearest is the variable to the highest degree starts, and then we just build down from there. So you could say this is the variable of x to the power of 0, because what's anything to that power of 0?
0.
Not 0.
1.
1. And then it'd be just 6 times 1, right? So that'd be a very low power, you could say, in that case. So we're going to change the order of those two. There's nothing wrong with that as long as we keep the signs in the correct order. So this should be negative 3x squared plus 6 divided by 2. Now, here's the key. We're still divided by 2, so it almost looks like it's a division of two functions. But you can split this. What this is saying is the first term is divided by 2 and the second term. So this term is technically divided by 2 and this term. So we'll split it into two separate terms. We're going to get y equals negative 3 over 2x squared plus, and then 6 divided by 2 is 3. So now when we look at this, I'm not sure if you recall, but when we're talking about quadratics, they usually write functions kind of like this. Your letters might be different from what I use, but they have an A, which kind of determines if it opens upwards or downwards. If the x is in brackets with another number, that determines if it moves left or right. And then a number on the end determines if the parabola moves up and down. So first of all, which of these variables is this referring to? Or what variable, sorry, do we have? What would negative 3 over 2 be?
That would be A.
Yeah, that's right. That would be our A term. So in other words, what this is saying, this is 1.5. So this parabola is actually going to be wider than a normal one. A normal parabola is written as y equals x squared. Okay? So because this is a negative 3 over 2, first of all, the parabola is going to, because it's negative, go downwards instead of upwards. And it's also going to be wider because A is greater than 1. Okay, so it's going to be wider. But for domain and range, the wider or the thinner doesn't make a difference because the domain's not going to be affected. Is there an h term here? Is x in brackets with another term in between?
No.
No, so h is 0, so the vertex is going to be on the y-axis. It's going to be at 0. And 3 is which variable? The k, which means the vertex is, because it's positive, going to move up 3 units. Okay? So what I mean by that when I go to graph it, let me get a graph out. And we'll zoom out a little so we can see everything. Okay, so when we go to graph this, the original graph starts at 0. You go over 1, up 1, over 2, up 4. Do you recall this at all?
Yes.
Over 3, up 9. So this is the original. So when we talk about moving, it's a little far from me. That's a little better. When we talk about moving from there, we're talking about moving from this parabola. So we'll call this the original one. It's not quite perfect, but the vertex is going up 3 units. So it no longer starts here. It goes up 1, 2, 3. And then from there, it's going down. Now, we could draw this perfectly, and I'll show you how to draw it perfectly, but for domain, it's actually not going to make a big difference. Normally, we go over 1, up 1. But because the a value is negative 3 over 2, you multiply 1 by 3 over 2, and actually we go, which is 1.5, we go over 1, down 1.5. 1.5. Then we go over 2. Usually we go up 4. Well, 4 times negative 3 over 2 is going to give us negative 12 over 2, which is 6. Whoops. So instead of going down up 4, we're actually going over 2 down 6. 2, 3, 4, 5, 6. So this is the idea. This is a thinner parabola than before, essentially is what we're making, okay? So that's what it's doing. Don't worry too much about the drawing now. Now, domain and range. What did you say the domain was?
X is all real numbers.
Yeah, that's right, because we know that it's going to go left and right forever. What will the range be on this one?
Y is all real numbers such that Y is less than or equal to 3.
Good. That's it. The tough part was getting the equation in a way that we could see that it went downwards and the vertex had been moved. Because for a quadratic, the vertex and the direction it opens is important for range.
Yeah. So then, if I just lifted it, I should have known that this opened down.
Yeah, because it's a negative.
This would have became 3, so it started at 3.
Exactly. That's what you're trying to get at. But sometimes it's best to look at the way we had it down here at the bottom, just because it's a little more common when we're looking at a quadratic in that version.